New Year and welcome back to Jackson Square. Today we'll be looking at TEAC 6.7D, which says I can generate equivalent expressions using the properties of operations: inverse, identity, commutative, associative, and distributive properties. So let's jump right in. Hopefully you've updated your page in your notebook and you're looking at the page that I'm looking at and you're going to follow along with me. So first we want to talk about the commutative property. So maybe your parents commute. They travel in between work and home. So commutative property means to move or to travel. So in commutative property, the numbers move, okay? The numbers are physically traveling. They're switching places. They're moving within the problem. So commutative means the numbers move. So let's find that definition. Commutative, changing order. The numbers are changing order. So we'll drag that here. So let's look at examples. What would that look like? The numbers are physically moving. And we need to know that commutative property is for addition and multiplication only. If I add 2 plus 3, I get 5. If I add 3 plus 2, I get 5. If I multiply 2 times 3, I get 6. If I multiply 3 times 2, I get 6. If I switch the numbers or physically move the numbers around in a subtraction problem like 7 minus 5, I won't get the same answer if it's 5 minus 7. So commutative means moving. So when I look at my examples, I see here 2 plus 3 is equal to 3 plus 2. 2 times 3 is equal to 3 times 2. This is an example of commutative property. The numbers have physically moved places. Okay? Associative. Associative property is about who you hang out with. Who's your crew? You have more than one set of friends. Maybe in the morning you hang out with Tiffany. Maybe in the afternoon you hang out with Samantha. It's about who you're associated with, who you're grouped with. So the grouping changes, okay? So when we talk about grouping, we're talking about grouping symbols. So the grouping symbol we'll see most often is parentheses. So we're looking for the parentheses to move, not the numbers. The numbers are going to stay still, but the parentheses is going to move. So let's see, where's our definition of that? Associate with different groups equals moving parentheses. So the parentheses is going to move for associative property. So here again, associative property is for addition and multiplication only, okay? Associative property of addition or associative property of multiplication. Associative property, and most of these properties are for addition and multiplication only, okay? So here I see 2 plus 7 plus 5. 2 is first, 7, and then 5. 2 is hanging out with 7, so they are hanging out. Then I see on the other side of the equal sign here, I see 2, 7, and 5. The numbers are in the same exact place, but now 7 is hanging out with 5. So it's like the parentheses shift from here to there. The parentheses moved, not the numbers. The same thing here with the multiplication. 5, then 4, then 2, then 5, then 4, then 2. 5 is hanging out with 4, and then after lunch, 4 is hanging out with 2. Okay? So the parentheses physically switched. So for associative property, it's about your grouping, who you hang out with, okay? Who's your squad? Who's your pod? Who's your group? Who's your posse? I don't know what y'all say these days. That's what it's about, who you're hanging out with, okay? Then we want to talk about identity property of addition or multiplication. Again, identity property has to do with multiplication and addition and multiplication, Identity. If I put on lipstick, did I change? No, I'm still Miss Jackson. If I did something to my hair, I'm still Miss Jackson. Whatever you do to me, you can add this number to me and I won't change. You can multiply me times this number and I won't change. So the identity property of multiplication and addition says, if you add 0 to me, I'm still myself. If you multiply me by 1, I'm still myself, okay? So identity property, I can get a new haircut, I can get a new outfit, but when I look in the mirror, I still see myself. My identity is still the same, okay? Identity property. So add 0 to keep the number's identity or multiply by 1. So this goes there. And what does that look like in numerical form? If you multiply me here, if 100 plus 0 is still 100. 4 times 1 is still 4, okay? The identity did not change just because you added 0. The identity did not change. The number did not change because you multiply by 1. Identity property says if you multiply me times 1, I'm still myself. If you add 0 to me, I'm still myself. Inverse property. So inverse property, this is a roll of film, okay? So I like to tell my kids, back in the day before digital, but after we had like Polaroids, we had film, okay? You would have to take this film, drop it in the camera, take your pictures. There was no preview. You had no idea what you looked like. You did not know. You would have to take this roll of film, take it to Walgreens, CVS, Walmart, drop it in. They develop your pictures, and then you'd come back later and you would see what they look like. And it's funny because I said develop pictures, and I got some pictures developed over Christmas of my family, but it wasn't from a camera negative, okay? So I have some pictures that I took to Walgreens and got developed. So inverse property, okay? Inverse, hopefully you know or remember, it means the opposite. So if you add my opposite to me, I'm going to be 0. If you multiply me times my opposite, I'm going to be 0. So that's what the inverse property says, okay? So if you, if you multiply me times my reciprocals, okay? My reciprocal. Remember, reciprocal is when the numerator and the denominator are physically switching positions. If you multiply me times my reciprocal, I'm going to be 1. Sorry, I think I said 0 earlier. I'm going to be 1. And if you add my opposite to me, I'm going to be 0. So let's see how that looks, and let's find that definition. Adding a number to its opposite. So we want to think about integers. The opposite of 5 is -5. The opposite of -3 is +3. Okay? And how would that look? Off my page. Okay. So how would that look? This is how it would look. -32 plus 32 is 0. I'm adding opposites, so they equal 0. Remember, they're the same distance from 0, but on the opposite sides. Okay, so they come back together. 4 over 1 times 1 over 4 will give me just 1. If you multiply me times my reciprocal. So that's the inverse property, okay? You're going to think about that film, inverse property. Then we have distributive property, okay? Distributive property. So I have candy here because distributive property makes me thinking about distribute means to give out. Okay, think about Halloween. When you walk up to those people's house and you say trick or treat, you want everybody to get some candy, right? Everybody there gets some candy. What if they said, "Oh, you're so cute. Oh, you're so precious. Oh, that's so imaginative. Oh, do better. No candy for you." You would be crushed. Your heart would be hurt. So distributive, everybody gets some candy. Okay, so distribute means to give out. Just like when your teacher is walking around the room and she's passing out papers, she's distributing them to everyone. So distribute means to give out. And so distribute means to give out, distribute the number to each part. Now, distributive property is only for multiplication, okay? There's no distributive property of addition, only distributive property of multiplication, okay? Only for multiplication. What does that look like? Well, this is what it looks like. 3. 3 is outside of the parentheses. So we know that a number next to parentheses, hopefully you remember, means multiplication. So we're going to multiply everything inside this parentheses, inside that grouping symbol, times 3. So you're going to distribute the 3. So you're going to end up in expanded form. It would be 3 times 7 plus 3 times 4. That 3 is being distributed to everything inside of the parentheses. And you'll get more practice and see this more, but we just want you to know what it will look like, okay? So this is what distributive property will look like. And last but certainly not least, my favorite of all times, 0. 0 is my hero, okay? 0 is so powerful. 0 is my hero. 0 is only for multiplicative problems as well. That means multiplication. 0, anytime you multiply a number times 0, the answer is going to be 0. 0 is my hero. He's going to knock them all out. If you multiply a number times 0, it's going to be 0. So 0 property is for multiplication only, and anytime you multiply a number times 0, your answer is going to be 0. Okay? Awesome. So please let's not get that confused with identity property, because a lot of kids do. Every time they see a 0, they think, oh, it's 0 is my hero. But 0 is my hero is multiplication. Identity property is if you add 0 to me, I see myself. So you have to look on the other side of the equal sign and look at what you see. If you see yourself, it's identity. But if you see a 0, then it's 0 is my hero. Captain 0 is amazing. Okay, so all we have left is now 0 times 5 equals 0. So that is what definitely goes in that box as our example. So hopefully you have been able to learn these, or at least get acquainted, and we're going to have lots more time to do this. But commutative property means to travel. The numbers are moving. We have associative, who you hang out with, who you're grouped with. The parentheses is moving. We have identity property, okay? When I look in the mirror, if you add 0 to me, I'm still myself. If you multiply me times 1, I'm still myself. We have inverse property. If you add my opposite to me, I'm 0. If you multiply me times my reciprocal, I'm 1. Okay, so it's all about doing the opposite. We have distributive property. Everybody gets some. Everybody gets a little candy. Everybody gets some. Give out. Okay, and we have 0 is my hero. If you multiply something times 0, you get 0. So, ladies and gentlemen, if you don't know, that's the train. So I think I finished this just in time. So let's go practice.